Before we write any program, we need to look into the coordinate system. The most common kind is the Cartesian coordinate system. You are probably quite familiar with this system because this is what you have used while plotting graphs in school. Let's go over how this coordinate system translates to CNC machines. This here is an example of a typical CNC milling machine. As you can see by the axis on the diagram, the table moves along the x and y axis while the z axis dictates the up and down movement of the spindle, which also controls the depth of cut. On a standard CNC lathe, these axes are slightly different. The z-axis runs along the center line of the lathe, whereas the x-axis runs at a right angle from the center line of the component. Let's get back to the graph and see how it works when we are writing a program. The circular symbol in the center of the graph is what represents the datum position or the origin. This is the point where the coordinates of x and y is 0. Any dimension above or right of the datum would be positive, and any dimension below or left of the datum would be negative. So our first point on graph would be 1, 1 when both x and y is positive or positive 1. The next coordinate here, as you can see, is 2, -3, which means x is positive 2 and y is negative 2. And hence it's below the datum position. Now as we move into the bottom left quadrant, you can see now the x and y values are both negative, and finally we have negative x and positive y in this quadrant. So overall, the top right quadrant or the first quadrant will always have positive and positive values. Bottom right or second quadrant will have positive x and negative y values. The bottom left or third quadrant will have both negative, and the top left or fourth quadrant will have negative x and positive y value.